All right, so welcome everyone. And for those of you who don't know me, I'm Melanie Tanilian. I'm the director for the program in International and Comparative Studies here in the International Institute. And tonight's event is co-organized by the Donia Human Rights Center and the program in International and Comparative Studies. And as always, before I begin, I would like to thank important people, Danielle Schmidt, who is our program specialist and who has been working hard to make this event possible. And I would also like to thank Natasha Gruden-Albegovic for the many, many years that she has put in working with tonight's speaker to provide internship opportunities for our students with Perseus strategies in DC. When most of us in the room, students and faculty, think about artificial intelligence, we worry about students writing your papers with ChatGPT. And that's about it. That's kind of what we worry about. Don't do it. But after this evening, I'm afraid that will seem really trivial and that your instructors would tell you, use it, knock yourself out, because in the grand scheme of things, this is really unimportant. On campus, there's a great buzz around artificial intelligence. There's 35 courses now taught on AI, its possibilities, its challenges, in this semester alone, so you can imagine what's going on. And as our provost recognized in today's Michigan Daily, actually, that there's tremendous research going on. Many of our colleagues, Michigan faculty, are engaging in research projects from wearable robotics and feedback through machine learning, as to how AI may, to like the point where AI may reduce actually your numbers of therapy sessions. Indeed, your mind, your brain, is what tonight's talk will explore. And as not simply a new frontier for technology and artificial intelligence, but also as a new frontier for us, human rights practitioners and educators, and you students, to contend with a new frontier in discourse, practice, and activism as human thought has become vulnerable to market exploitation and surveillance. As neurotechnologies, meaning devices that are capable of recording, interpreting, and altering your brain activity, are developing really in lightning speed as we speak here. They have led to tremendous medical and fabulous breakthroughs in other scientific fields. Neurotechnology has helped patients with paralysis to regain their ability to communicate. For instance, there's been groundbreaking research been done in the realm of Parkinson's. For people who are visually impaired, neurotechnology has made great contribution. But neurotechnology has not been immune to market forces, and of course we know nothing really ever is. So we have brain boot camps, right? You know those little programs that tell you exercise your brain. We have snooze aids for academic brains that chatter just too much. And we even have toys that you may control by sheer concentration. And of course, that all sounds super exciting. It's like discovering a new cheat code for life. But we cannot ignore the fine print, unfortunately, in this case. We're talking privacy pitfalls. AI that potentially can decode your thoughts faster than you can say neurotechnologies, and the terrifying notion of someone messing with your mind. Welcome to the age of brain tech, where innovation meets interference. Your thoughts might not be your own very much longer. Sounds utopian, but maybe it's not. Joining us tonight to alert to the unique human rights challenges posed by neurotechnologies and the great urgency for us of thinking about ways forward in international human rights is the human rights lawyer, co-founder of the General Counsel for the Neurorights Foundation, Jared Genser. He will explore the implications of neurotechnology on existing legal, ethical, and regulatory regimes, pulling directly from his expertise in advising the United Nations, industry partners, and governments around the world on just this topic. What does it mean to have the right to your thought? And for us to advocate, as Jared writes, I quote, for the right to mental integrity, the right to mental agency, the right to mental privacy, the right to fair access to all of these beautiful innovations, to mental augmentation, and the right to protect from algorithmic bias. I love that line of questioning that you are putting on the table. So Jared Genser has been a quite frequent visitor to PICS and also to the Donia Human Rights Center. And it's always amazing that you come up with something completely new. I mean, I have heard many of your talks, but it never is anything where I would think, oh, he's going there, no, you know, or he's going to talk about a particular topic. So this is very new for me. Neurotechnologies. But Jared has been an international human rights lawyer for more than 2 decades. He holds a BS from Cornell University, an MPP from Harvard University's John F. Kennedy School of Government, and most importantly, of course, you hold a JD cum laude from the University of Michigan Law School. He currently is the managing director of Perseus Strategy, a public interest law firm, and works as the special advisor on the responsibility to protect to the Organization of American States. I want to really hear about what's happening there. Genser has taught law at Georgetown University and also at University of Pennsylvania, as well as here at the University of Michigan. And over his career has advised multilateral institutions, governments, companies, foundations, and civil society organizations on ensuring that their work was consistent with international human rights, labor rights, and environmental rights standards. I'm telling you, it's a lot of topics here that we could explore. He has been referred to by the New York Times as the extractor. That must be your favorite title, right? For his work on freeing political prisoners worldwide, coming from his experience of freeing his first client as a law student in 2001. And he founded out of that experience what is called Freedom Now, a non-governmental organization that works to free prisoners of conscience worldwide. Most recently, his firm was instrumental in freeing American citizens who had been imprisoned in Iran. He has served as pro bono counsel for 5 Nobel Peace Prize laureates, including Archbishop Desmond Tutu and Elie Wiesel. Genser, others past clients have included the Czech Republic President Václav Havel, the Malaysian Prime Minister Anwar Ibrahim, and former Maldives President Mohammed Nasheed. He has won numerous awards, too many to count. And if he's not busy enough, he's also writing. So he has published a book on the UN Working Group on Arbitrary Detention, a commentary and guide to practice by Cambridge University Press. He has written on the UN Council in the Age of Human Rights, the responsibility to protect, the promise of stopping mass atrocity in our times. Not so sure about that promise. He currently is working on an Oxford Handbook. That's a really big project, I assume, on UN human rights with the former UN High Commissioner for Human Rights, Zeid Ra'ad Al Hussein. And lastly, I want to thank you and say that Jared has been a fantastic mentor to our students through the Donia Human Rights PICS Perseus Strategy International Human Rights Fellowship. It's a really long title. And those students of you who are here and are going to be around, this is a fabulous opportunity where every year Perseus Strategy provides an invaluable internship for 2 of our most outstanding students. Among them is Hannah Pierce, who is also here with us. and who's currently the Archbishop Desmond Tutu International Policy Fellow with Perseus Strategies. And so publicly, I want to thank you so very much for all that you've been doing and the great service you have done to our students in this context. So thank you very much, and I'll invite you up to stage. So help me welcome Jared to talk about neurotechnologies.
Well, that was some introduction. Thank you so much for the warm welcome. It's always great to be back here, of course, at the University of Michigan, and to be speaking here today before the Dania Center, which is one of our nation's preeminent human rights centers at a university really in the United States, doing such important work in a wide array of ways. And I'm personally just as grateful for the partnership that my public interest law firm has had with the Dania Center and PICS in helping ensure that we have an extraordinary staff that come and work at our firm. We are a very small and scrappy law firm with only 4 full-time staff. And we've had every summer now 2 fabulous Michigan students come to join us. And Hannah was one of our interns, and then later we were able to hire her back full-time to join us. And she just happens to be in Ann Arbor because, of course, she went here as well. So in terms of, what are we here to talk about tonight? What I'm going to be doing is talking about how to promote innovation in neurotechnologies while also protecting human rights and ensuring its ethical developments. And there are a lot of different topics I'm going to talk about, because what I found as I travel around the country and around the world is that on this particular topic, and it was noted before I talk about other topics, unless you're in the tech space yourself already, you're probably going to only know some very high-level things about what neurotechnology is, and you're probably not going to actually have a full or complete understanding about how quickly it's developing and where it is heading. And so a big part of what I really try to do in these talks is to help bring people up to speed about where things are, and I think that you're going to find this to be an incredibly compelling and an eye-opening discussion, because almost everyone that has no background is generally shocked by where we are and where we are going. So we're going to begin by talking about what are neurotechnologies. And so here we're talking about some basic definitions. As was mentioned, neurotechnologies are devices that record or alter the activity of the brain or the wider nervous system. When we're talking about neurotechnologies operate through what are called brain-computer interfaces or brain-machine interfaces. It's the same thing, it's just an interchangeable word. I'm going to use the term BCIs. And these are devices that connect brains to computers, machines, other devices, and that facilitate bidirectional communication from the brain to the device, from the device potentially back to the brain. And this is how they operate and function. Neural data is what these devices capture, and neural data, in essence, are the electrical signals being sent by your neurons as they communicate with each other and generate everything that there is in our worlds and what it means to actually be human. And the neural data that is, of course, being measured, and then ultimately decoded, and potentially even things are being written back to a person's brain as well. There are a range of ways to measure brain activity. You may have heard of an EEG. That's typically what people might have had experience with if they saw a doctor on some kind of an issue. And that's a direct method to measure electrical impulses in your brain. Indirectly, you can also follow blood flow like an fMRI machine does. So you're indirectly measuring the firing of your neurons in your brain. And there are a lot of different other ways in which this can be done. And then lastly, there are 2 different kinds of neurotechnologies. They're quite different in a dramatic way. And the concerns that one has about each of these 2 different ways in which neurotechnologies can be deployed are quite different as well. There are invasive neurotechnologies, which requires neurosurgery, where your skull is pierced by a surgeon and a device is implanted in your brain. Or in your brain, either on the surface or inside the brain itself. And then there are non-invasive devices, which are wearable devices, which are caps, hats, helmets, or wristbands. But why do we care about all this in the first place? And this is because the human brain is different than any other organ in our entire body. It literally generates everything about who we are: our thoughts, our emotions, our concerns, our relationships that we have with people in the world, our memories, our dreams, our entire cognitive reality is generated by our brain. And as a result of that, data coming from one's brain, especially given how quickly these technologies are developing, are going to ultimately be able to be decoded in enormous ways that are going to provide enormous insight into how the brain operates and functions. On the one hand, that can be an amazing thing and a really incredible thing, especially in a medical context. Today, there are no cures for any brain diseases. All we can do is diagnose them, and in some cases, you can slow their progression. But it's expected with neurotechnologies in the future, we're going to actually be able to not only cure brain diseases, but to potentially even reverse their effects. We're not there yet. We're not close to there yet. But this is the direction that we are heading when you especially combine neurotechnologies with AI. Similarly, all the different kinds of things I just mentioned, your dreams, your thoughts, your emotions, some of them can already be decoded today, in fact, and I'll be talking a little bit more about that. But there's, to me, when one thinks about international human rights or about human rights as a general matter, given the brain generates our entire realities and the world in which we live and how we perceive that world, right? Nothing could be more of a human rights issue than the content of our brains and how that can be decoded and potentially altered. So I want to provide some examples of neurotechnologies. First, I'm going to start with two older kinds of neurotechnologies that have been around for a while. One is called deep brain stimulation. That was just referenced a moment ago. And that involves making small holes in the skull to implant electrical devices that look like that little picture there into the right spot of the brain that can help treat medical conditions like Parkinson's, epilepsy, Tourette syndrome, and obsessive compulsive disorder. And these have been around for several decades and have been used very, very effectively to, again, ameliorate symptoms, not cure the disease. And the other kind of device that's been around for a long time are cochlear implants, which are especially used for people who have little to no hearing at all. And there is both a microphone placed by the ear to hear what is around, and then you have an implanted receiver stimulator under the skin that collects the electrical impulses and sends them into the auditory nerve so that they can be decoded into hearing. But there are a lot of other examples of invasive neurotechnologies, and the way this is developing, is actually quite extraordinary. So this was in the New York Times, published just this past August, and was an extraordinary step forward in advancing neurotechnologies. It was on the front page above the fold in the New York Times. And this is about a researcher and medical doctor, Edward Chang, out at UCSF in San Francisco, who, by implanting neurotechnologies right inside of the skull in a number of different places on a woman's head. This is a woman who, for the last 18 years, has been fully paralyzed and totally nonverbal, unable to communicate with the world. Not only has her speech been able to be decoded, but it's also been projected onto an avatar of her. And you're not able to just decode human speech. With an implantable device today, you can decode, you'll be interested to know, human thoughts can be decoded at a speed of 20 words a minute with 94% accuracy. So if you think mind reading is science fiction, it's actually already science with invasive devices. But also, even though her face is paralyzed, her brain is still trying to send signals to her facial muscles to move her facial muscles and emotion, to express emotion, and those are also being decoded and projected onto the avatar. So this is just a quick excerpt of what this looks like. I don't know if we have any volume here or not, but there's you'll see that there's words underneath the screen. This is her son talking to her and talking to this woman. That's what the avatar looks like. And she's talking about the Blue Jays and whether or not they're going to win, the next game, right? And so she's not moving her mouth, but you're hearing the words coming out, and it's being projected onto the avatar, and that's very quickly what it looks like. So this is another example of what can be done with implantable brain-computer interfaces. You may have also seen this news report from this past August. So there are a group of 29 people who have epilepsy who had deep brain stimulation in their brains already to treat them for epilepsy. And when they came into the lab to have their implant checked out and for their regular treatments, they were asked, "Would you be willing to listen to a Pink Floyd song, Another Brick in the Wall, Part 1?" Because it turns out that where you have to put the brain-computer interface for epilepsy is not far from the auditory cortex. And that same device that was used there was then used to capture the electrical signals that was being heard. And then you can see here the electrodes that were already there for another purpose not only detected neural signals, but rhythm, harmony, and other musical aspects. As you can find online, actually, comparing that 15-second clip that was played with what you can decode from what's in the human brain, and it sounds about 60 or 70% of the same thing there. If you knew it was Pink Floyd and you knew anything about Pink Floyd, you'd probably know the song well enough from there as well. I'm not sure if there's a tech person here, but it stopped projecting onto my screen here. Okay, so what are some examples of non-invasive or wearable neurotechnologies? Perfect, thank you. So this is an older one, but you may or may not remember that in 2014, there was a person who was paraplegic who, wearing a robotic suit and Neurotechnologies, was able to actually kick the ball. Had their mind instructed this robotic suit to kick the ball to open up the World Cup. Which is pretty extraordinary because we're talking about a wearable device here being able to power a robotic exoskeleton, which sounds very much like science fiction, but actually has been science for 10 years. Another example, which is extraordinary, is that a person who's quadriplegic, who actually used to be a race car driver, but was almost killed in a crash and then paralyzed, is now actually starting to race again using a wearable brain-computer interface that can decode where he wants the car to go and how to turn and when and how, even at those high rates of speed, which is, again, pretty extraordinary. I don't know that I want him on our roads, especially when you see self-driving cars, for example, or other challenges out there. But this is something that he's now actually able to do again. And then it isn't just that you can decode human thought with an implantable device today, but you can also decode images that you see and get translated into words as you look at them. And so this is an excerpt from a study that was done a number of years ago where a person came to a lab. They were shown several hundred pictures of different images, and an fMRI scan was capturing what their brain looked like when they saw these different images. And then they were shown a video, about a 30-minute video, and throughout the video, what you can see on the screen is because when they're seeing these images, it matches the images that they've been seeing before. Therefore, the neurotech device can decode, this matches, water or sky or building, et cetera. And you see the words fading in and out as they're in the person's thoughts, right? And it's based on decoding of an image. So beyond that, higher profile examples, there are actually already 30 consumer neurotech products that are available on the market today for 3 sets of purposes: wellness, entertainment, and at-home research. These are some examples of the different devices that you can already purchase right now online. And I'll get back more to that as well, because one of the things that makes this a current set of issues that one needs to look at from a matter of human rights is the way in which these consumer neurotech products are not actually regulated at all in the US or really around the world, and the implications of neurotech devices harvesting brain data, which can be used for many different purposes, not just the narrow purposes for which these devices operate. This is another device that's quite interesting, which was mentioned a moment ago, but with an EEG headset, you can fly a helicopter drone by thinking about where you want it to go. And the neurotech device decodes where you're thinking about it wanting to go, and the drone will fly in those different directions. I've tried a different version of the same device, and it's extraordinary. I mean, it's really, you have to work with it a little bit to kind of get used to how to do it, but then it's following your instructions based on your thinking, which is rather surreal, I would say. So why are neurotechnologies advancing so quickly? I was talking about that at the beginning as well. And there are 3 reasons. The first reason is that there's been an enormous amount of public and private investment into neurotechnology. President Obama launched the BRAIN Initiative in 2013. That's already put in more than $6 billion into research, into brain science and neurotechnologies. China is investing $8 billion through 2030. All that money is being invested through its military. One can imagine when they're spending $1 billion a year on that, what that's going to generate. There are a lot of other global brain initiatives as well. More than $33 billion have been invested into neurotech companies, and the market for brain-computer interfaces is growing almost 20% annually, and is expected to reach $4 billion of annual sales by 2027. So this is growing fast. The second reason why neurotechnologies are developing so quickly is because of major advances in BCIs and BMIs, right? An EEG scan is a relatively basic brain scanning device that only has a certain level of resolution that would not enable you to decode, for example, a person's subconscious thoughts. One day we will be able to actually decode subconscious thoughts. We're not there yet. But one of the most important developments that we've seen in the field of neurotechnologies was 3 years ago, the announcement of the kernel flow helmet. And the kernel flow helmet is basically like compressing an MRI machine, which can cost $500,000 to $1 million, into a wearable scanning device, and has that level of resolution very similar to it. It does it through optical lasers and not through magnetics, which is a distinction without a difference. But the bottom line is that these helmets have exceptionally high resolution and will ultimately be able to look into every part of your brain and ultimately to decode an enormous amount of what is in there. Today, with scanning technology, we can only decode about 1% of what is in a brain scan, and it's expected just in the next, let's say, 3 years, that's going to increase to 3 to 5%. And as you have high-resolution devices combined with advances in decoding technology, you're going to see, major breakthroughs. And of course, once the price of this kernel flow helmet, which is now about $50,000, drops substantially and becomes the BCI of general use for hundreds of dollars, then what you're going to be able to decode from wearable devices is going to grow exponentially. The last reason for the advances has also been generative artificial intelligence. And I always find it interesting, to have heard that there are 30 classes on AI just this semester, and probably no classes on neurotechnologies. Maybe somebody at the medical school or something might be talking about it. But the reality is that generative AI are powering enormous advances. My colleague, who I'll talk about in a moment, Dr. Raphael Yuste at Columbia University, with whom I'm working on these issues, and is one of the world's leading experts on neurotech, has said that advances that he thought would take 5 years, let's say 2 years ago, are now happening in 2 years. And he is shocked, even as a guy who spent his entire life and career as an MD, PhD running the Neurotech lab at Columbia, he is shocked by how quickly this is coming along. And you can see here in this last bullet point a very, very important thing that is happening now in Sydney, and undoubtedly others are quietly working on this as well, which is, to me, the breakthrough moment for neurotechnologies, which will match the breakthrough moment that ChatGPT was for generative AI, is going to be the moment that we have a wearable brain-computer interface that will be able to decode, human thought at the 90% plus level of accuracy. But already, just using an EEG scanner, which, as I said, is lower resolution, and generative AI, researchers have already been able to demonstrate that they can decode silent human thoughts and convert them into text with 40 to 60% accuracy. My colleague Raphael Yuste at Columbia would say you're talking maybe 2 or 3 years before there's a device that we will be able to wear and decode our thoughts. And when that moment happens, it will be a huge revolution, both potentially in positive as well as in negative ways as well. So I now want to kind of transition to talking about neurotechnology and the potential risks of misuse and abuse of that technology, and the ways in which we are looking at these kinds of concerns as a matter of human rights. So to set the context, I was just mentioning my colleague, Dr. Yuste. I got involved in this work from a conversation I had with him 4 years ago. We were introduced by a mutual friend. And in a 1-hour conversation with him, my entire perception of my place in the world as an international human rights lawyer was transformed. Because when I started to hear about what he had been doing, what was coming and where it was going, much of which you're seeing and will see tonight, I realized that for me, as an international human rights lawyer, to not be working on these issues would be astonishingly, would show an astonishing lack of vision once that world was opened up to me and I understood where we were and where we were going. And he's always cared about the human rights implications of his work, but what really triggered his much more intense focus in this field of the intersection of human rights and neurotechnologies was an experiment that actually he did himself in his lab a decade ago. And this was an experiment with a mouse. And what you can see on the left side of the screen is that a mouse was shown on a little screen in front of it, a series of white bars going across a black screen from right to left. And the mouse was taught that when you see the bars going across the screen, lick the sugar syrup that is right in front of you. And when the TV screen is turned off, stop licking the sugar syrup. And he got the mouse very, very well trained. Now, of course, a mouse's brain, much smaller than a human brain. And it turns out if you look at a mouse's brain and the visual cortex, that when the mouse is seeing these bars moving and is licking the sugar syrup, only 500 neurons are firing. And on the right, you see a picture of the neurons firing in the brain. It turns out that, and this was captured with an fMRI scan. And then when you capture that in real time, you not only see the neurons firing, but the sequence in which they are firing as well. And whenever the screen is on, they fire in exactly the same way. And when the screen is off, they fire in different ways. With an implantable brain-computer interface at that spot in the visual cortex, you can actually play a mouse's brain like a piano and cause those 500 neurons to fire in the exact identical way as they are when the mouse is looking at the screen. And when you do that, you may not be surprised to learn that the mouse licks the sugar syrup exactly the same way as if it was seeing the image of the bars moving. And what you've done is projected a hallucination into the brain of the mouse. It's actually gotten even more, more Frankenstein from there, because it turns out that there are a lot of other things you can do with a mouse because of its relatively small brain and the smaller number of neurons. You can actually, literally implant a device in the mouse's brain that controls the movement of its limbs, and with a joystick have a mouse move according to the directions you want it to go in. Because you know what the mouse's brain looks like when it's moving a foot forward and these kinds of things. So this obviously scared him enormously, because what can be done in a mouse today can be done in a pig tomorrow, a chimpanzee after that, and ultimately a human. Now, we're very far off from projecting hallucinations into people's brains, to be very clear, but not so far off as it's not something that you could think might be possible in our lifetimes. So what he did in response to this was his experience here is he brought 25 of the world's leading experts together on neurotechnologies, including people from brain initiatives from around the world, including from the China Brain Initiative, a lot of other tech experts and ethicists. And they came up with this paper that they published in the peer-reviewed way in Nature magazine, looking at ethical priorities for neurotechnologies and AI. These ethical priorities are in essence identified areas of potential misuse and abuse that you would hope would be able to be protected against as these technologies advance. And so these are the 5 neurorights that were just being mentioned briefly before that we're talking about. And to be clear, when we're talking about neurorights, we're not talking about developing new human rights, but rather the further interpretation of the existing set of rights, which are quite robust in the world, and ensuring that they cover the potential misuse and abuse of neurotechnologies. The first is the right of mental privacy. Obviously, we should be able to protect our brains from being intruded upon without clearly understanding that that's going to happen and the implications of that. There's a right of mental identity, to be able to control our identity, and if there are changes that could be made to one's identity over time, that's obviously wholly within the control of the individual person. A right to agency or free will, right? You should be able to make decisions for yourself and not have decisions imposed upon you as it relates to anything that is happening in your brain. A right to be protected from bias in how these technologies are developed and applied. And then lastly, there's going to be a serious issue of fair access to mental augmentation, which again we discussed a little bit and I'll talk about a little bit more. So now I get to a fun part of this presentation where hopefully many of you will have seen The Matrix, at least at some point in your lives. Neo's offered the red pill or the blue pill. It's ironic, of course, because this is also a film that actually is about, in essence, all of humanity being imprisoned by neurotechnologies, because they're all living in virtual worlds that are being projected into their brains while their bodies are being used as batteries for these aliens. But nonetheless, I think it's important to kind of think about nightmare scenarios that are not on the distant horizon, but that are in the very near future. And so let me walk through a couple of them. The first is mind reading, which I've just been discussing. The reality is that once you have a wearable cap that can engage in mind reading with a high level of accuracy, imagine, for example, a political prisoner being interrogated by a dictator or the dictator's cronies, and being able, that person not being able to stop thinking about certain things when they get asked questions, right? And not being able to control their own ability to keep their mind blank, and being able to reveal who they work with, what their strategies are, what they do, where they have money, and everything else that a person can be interrogated to do. The second area of for me, gigantic concern as a human rights lawyer is torture. We are on the cusp of where physical torture will never be necessary again, which on the one hand you might say is a good thing, but maybe not when you see what the alternative is going to be, which is that neurotechnologies are already being used to start to treat more mild forms of chronic pain syndrome, which generally involves misfiring neurons in a person's brain where you think you have pain in your hand, there's no external stimulus, but you feel the pain anyway, and your neurons are misfiring. The most severe form of that disease is called complex regional pain syndrome, CRPS. It's called the suicide disease because 80% of the people who are diagnosed with it, and these are people who are feeling the most excruciating pain a human can feel, commit suicide. 80% commit suicide rather than continue to go without any treatment to that disease. Given the success that's already been seen with more mild versions of chronic pain syndrome, it is inevitable that we will ultimately be able to stop chronic pain, which will have an amazing impact, as you can imagine, all around the world, and even better, if it, of course, could be then ultimately with a wearable device. But once you're able to turn off the neurons misfiring in CRPS, you're going to also know how to turn them on. And in the nearer term, these are solutions that would be with implantable devices. Over time, though, anything that can be done with an implantable device will eventually be able to be done with a wearable device. It's just a question of the complexity and the time and the resolution and so forth. Once you're able to turn on a person's pain receptors that is equivalent to the most pain a human can feel, all it will take is for a nefarious actor or bad government to tie a person to a chair, put that on them for 5 minutes, and say, "You want to continue with your activities, or should we put this on for an hour? How about a day? How about a week?" Right? And the reality is that nobody's going to be able to resist that kind of torture, and frankly, dictatorships will also be able to use this to scramble the brains, in a very non-medical sense I'm saying this, of people, because I can't even begin to imagine if you force a person to be tied to a chair and were to leave that on for 24 hours, how would they be at the end of that, right? I mean, one can only imagine how terrible that would be. A third area of nightmare scenarios, and as with the torture and the mind reading scenarios, there's both good and evil that can be done here, relates to the disruption of impulses. On the positive side, BCIs have been used in obese mice to disrupt the gorge impulse that a mouse experiences when they see a very highly caloric, let's say, piece of cheese. And if you put a implant right in the spot where the brain lights up with that impulse, and you give it a little electrical shock, the impulse, the neurons turn off and the impulse disappears, and the mouse doesn't eat, just kind of looks at the cheese, and the mouse loses weight over time. There's now a human experiment underway with the exact same approach, and that's potentially a really, really good thing, of course. But the problem is that, how else could this kind of approach of using an electrical stimulus to disrupt firing neurons be used? One area which could be a positive thing could be with child, sex offenders. And if you're a convicted sex offender, obviously chemical castration is one option, that can be undertaken. But, while you couldn't stop a child sex offender who'd been convicted of feeling urges to molest children, you could disrupt that urge and turn it off, which would then create the motivation that would come with that urge, right? And reasonable people might have very different views, civil libertarians versus victim advocates, about whether or not, for example, if a person convicted of that crime should be required to have such a device that works. But you could also imagine that in the same way that any person's sexual urge could be disrupted if you put something in the spot where that urge appears in your brain activity, could also be urged in the case of some people who somehow believe that being LGBT is a terrible thing or a wrong thing or a ungodly thing if you were hyper-religious and believe these kinds of ridiculous assertions. But you can imagine that people who genuinely believe this, let's say, and are ultra-religious and somehow believe that homosexuality or being LGBT is a terrible thing or a wrong thing. You can imagine parents, if they knew that their child was gay, wanting, forcing them to have an implant in the part of their brain where that same-sex attraction would light up, to disrupt it. Again, it couldn't stop them from feeling those things, but it could stop them from wanting to act on those urges by disrupting those urges. I can't imagine a worse form of torture for a person than being put in a situation like that. So, 3 more quick examples of nightmare scenarios. The use of the criminal justice system. The reality is that Neurotechnologies will be able to identify individuals at risk of committing crimes based on neural markers, because neural data can already be used to show predispositions to specific psychological and behavioral traits. In addition, in the criminal justice context, the kernel flow helmet has actually already been used anecdotally as a lie detector, and I've actually seen this in process. And a person telling a lie and a person telling the truth about the same topic, their brain signals, not surprisingly, where are the neurons firing in their brain, are totally different. I mean, even as a person with no medical training or background at all, I can tell this does not look like this at all, right? And unlike, with a traditional lie detector test where a person who's well trained can beat that test by controlling their breathing, their pulse, their thinking, et cetera, right? Because of the nature of the billions of neurons we have in our brain, you're not going to be able to control what neurons in your brain fire. And imagine a scenario where we have, in the not too distant future, an unbeatable lie detector test. And what are the implications of that going to be? Would there be people who would say, let's save money on criminal justice by mandating, a disruption of our constitutional rights and saying, if you want to get out of being accused of a crime, you can request the use of this lie detector test, which will prove, that you weren't involved in the crime. Of course, there are lots of other problems with that as well. For example, oftentimes people might feel guilty about having done something, even if they didn't actually do anything wrong, and so there's lots of ways in which this could still be misread. But the idea of an unbeatable lie detector has both upsides and downsides to it. Another is really, and this is where we're really getting into the realm of what feels like science fiction, but is not far from it, which is about designer personalities. It turns out that over decades of experience with deep brain stimulation that is used to ameliorate the symptoms of brain diseases, a very small percentage of people who have deep brain stimulation actually experience a personality change, like 0.1%, as I understand it. And there's one, particularly well-known case of a woman who, she has Parkinson's, and with the stimulator on, her symptoms from Parkinson's subside, but she goes from being, as she has been her entire life, very much of an introvert to a very gregarious extrovert, to the extent that her family doesn't recognize her or her personality. And she likes her extroverted self, which begs almost a philosophical question, which is, who is she as a human? Is she a woman who's an introvert or a woman who can now be an extrovert? And what's very, very interesting about this, and scientists are studying this intensely, is, you have a perfect test case to look at this question because you can turn the machine on and off, and you see what neurons are firing when it's on in what parts of the brain, and what neurons are firing when it's off in what parts of the brain. And if scientists are able, and there's every reason to think that they should be able to with sufficient time, find the part of the brain that really, or the different parts of the brain that connect together to make someone extroverted, then with an implantable brain-computer interface, you should theoretically be able to actually have an implantable device or even a wearable device one day that could enable a person to become extroverted if they were an introvert. Or the reverse. And of course, this, as I said, if this isn't a human rights issue, I don't know really what is, but imagine a scenario where the company that's providing her this service is going to go out of business. Does she have a right to keep her new self and her new personality? And on what basis? So these are all, very, very interesting questions and potentially troubling ones as well. And of course, one of my biggest fears, although I put it last because it's less dramatic than the ones up front, of course, is the development of neurotechnologies as a driver of inequality in the world, of which there's already gigantic and enormous inequality in so many different ways in our world. Right now, there's actually some BCIs that are wearable devices that that these companies assert are helping to improve short and long-term memory. There have not been scientific evidence to demonstrate that yet. But my colleague, Dr. Yuste, strongly believes that in the next few years, we're going to have devices that will be able to improve human memory through electrical stimulation to the right places and in the right ways. And imagine a scenario, let's say at the University of Michigan, where that technology comes on the market and is available. And, there are students here who are paying their full way because they come from wealthy families, and there are others here who are on financial aid. And, imagine a scenario where you're sitting in a classroom now where, at nighttime, half the students or a third of the students are going home putting on their memory enhancing devices, and you're taking tests and being graded on those tests, having to compete with other students who have already been able to substantially enhance their own short and long-term memory. And how does one think about dealing with a situation like that? This is not too far off. This is a few years away, maybe a little longer, but not 10 years, not 20 years. So my colleague, Dr. Yuste, and I, we created the NeuroRights Foundation along with another colleague. And you can find more on our website about that, neurorightsfoundation.org. But we created the NeuroRights Foundation to talk about what we are, these 5 neurorights, these risks of misuse and abuse of the technology, and trying to help both internationally and nationally around the world begin to put in place the kind of guardrails that are necessary to not only project to the world that this is coming and really quickly, but also to protect against these kinds of misuse and abuses of the technology itself. So now let me talk a little bit about why this is also a problem right now and not just a future problem. The 6 nightmare scenarios that I just described are not all here now. The wearable BCI to decode human thought is probably the closest one because they're already doing it 40–60% accuracy with an MRI and generative AI. So it's really, we're talking a year or two maybe to have that kind of wearable hat. Obviously, to go to market will take longer and everything else, but I mean, that one is right here. But there's also another reason why this is a problem right now. And this comes back to what I was describing before as the distinction between how implantable devices and wearable devices are treated by the law. Invasive neurotechnologies, which of course require brain surgery, are strictly regulated as medical devices and are subject to health privacy laws, rules, and regulations. So we are not especially concerned about implantable devices because you can't just willy-nilly, if you're a doctor, come up with some device and go stick it in a patient's head, right? You have to go in the United States through the FDA to get approval. You have to have clinical trials and all the rest of it, right? And if you were to reveal any of that person's medical history, if you were a doctor, to any third party, then you're going to have a serious problem violating HIPAA and state privacy laws. And so we feel like neural data that comes from a medical and healthcare context, is well protected right now and not something that is our big concern. But unfortunately, it's the opposite end of the spectrum when you talk about non-invasive devices or wearable devices, as I was talking about, because oddly, it's odd to look at from a distance. It makes sense when you think about it a little bit more, but you're talking about medical grade brain scanning devices like EEGs that if you were to use it in a medical context would have been licensed by the FDA and regulated and all the data protected by health privacy laws. But that very same kind of device is now being deployed in a consumer context. And consumer products are not regulated in the United States or really around the world in any major way except for safety concerns. For example, in the US, we have the Consumer Product Safety Commission, and if a consumer product is dangerous, it can be regulated. But just simply protecting the data from it is not regulated. There's also in the United States no federal privacy laws that generally protect consumers. There are only specific protections for areas like healthcare data and financial data. So there's really no regulation at all for these 30 companies I was just mentioning. And so you can buy on the market any of these products of the kinds that I was describing. Your brain data is being scanned and being used however the companies want to use it. And you have no legal protections of any kind in terms of what might happen with that. Now, you're probably not going to recognize the name of most of these companies because they're, a lot of them are startups and they're doing lots of different kinds of things, and none of them are household names. But there are some household names that you will recognize that are right now running full speed towards developing and deploying consumer neurotechnology products. Meta, for example, acquired Control Labs for about $1 billion, which is a neurotech company that actually was founded by a guy named Tom Reardon, who's a former dissertation student of my colleague, Raphael Yuste. And they are developing a wristband that will capture neural activity from the wrist. It turns out, by the way, that, again, I don't know anything about the science, but I've learned an enormous amount along the way from my colleague. But it turns out, for example, if you're thinking of moving a mouse, right in front of you like that, if you think about moving the mouse, then signals are sent from your brain to your peripheral nervous system, and the intended movement can be captured at your wrist even if you don't actually move the mouse, which means that by just thinking about moving your hand north in a mouse, you'll be able to have the mouse on the screen move without actually moving your hand because you're wearing the wristband that will be able to decode it. Similarly, there will also be the ability to click on a mouse, for example, with like a micro movement of your fingers and lots of other cool things. Then you have Apple. Apple in 2023 filed a patent for next generation AirPods that are going to have built-in EEG sensors in it, brain scanning devices. And the patent application talks about capturing biosignals and electrical activities from the brain. You're not required when you apply for a patent to declare how you intend to use that patent. So we don't yet know how Apple is going to use this next generation AirPod. As a starting point, it would seem natural that it would build on the health-related applications of the Apple Watch, but it could do a lot more than that. I mean, that kind of device, because it's in the ears, is actually very close into the brain. It's a great place to put an EEG scanner. And for example, as decoding human thought into text becomes possible with a wearable device, that device could be purposed in that way. Right now, we don't know how they're going to use it, but obviously, the moment that happens, there will be wide adoption of that kind of device. And then Snap, which owns Snapchat, also acquired a neurotechnology company for its augmented reality and VR products. And in essence, what they're trying to do is to create a wearable device that in a VR world will enable you just by thinking of it to do things in that VR world, such as if you see 3 buttons in front of you, you can just think of which button you want to press, and that will be decoded from your brain, and the button will be pressed in your virtual reality world. The moment that any of these products go on the market, millions upon millions, tens of millions, hundreds of millions of these products are going to be sold. And so this is why our foundation is just about to publish in the next 2 weeks a major new report on these 30 publicly available consumer neurotech products, and particularly looking at the privacy practices of these products today. And so this is a report that we put together. I'm going to give you a preview of it. I don't think there's any journalists in the room, but I'd ask you not to share this with people, at least until we go public with this report in 2 weeks, or less than 2 weeks. But I wanted to kind of give you a preview of that whole report. So first of all, how did we conduct our work? We looked online to find every product we could find that is available for public purchase, either currently or for pre-orders. And we found 30 different products. And the products themselves that we selected were only products that were available to consumers and that actually collect neural data. So we're not looking for business-to-business products. Like right now, the kernel flow helmet can be bought for $50,000 and is being used for research and other stuff. That's not a consumer product. No one's going to buy that helmet for $50,000. And frankly, you can't do anything with it unless you have software applications or other stuff like that. From there, we looked at each of these products and the company website, and we gathered any and all policy documents that we could find online, privacy agreements, terms of use and sale, end user license agreements, et cetera. We then reached out to the companies individually. All of the companies, as you'll see in a moment, provide a means to contact them either through an online form or through an email. And we reached out to them up to 3 times if they didn't respond, saying, is there anything else you think we should know? Because we're doing this study and we're looking at these agreements and so forth. And then from looking at these documents, we then identified 5 areas of concern for review, which are access to information, data collection, data storage, data sharing, user rights, and data safety and security. And then what we did is we coded all of these policy documents from each of the companies across a range of different specific concerns within the 5 areas for review, and then we benchmark them against global privacy standards to see how do they compare to what global privacy standards currently say today. The first 3 are binding law on countries that are, for example, in the EU, the General Data Protection Regulation applies to all EU member states and is binding law within the EU. The African Union has a convention. Any country that's signed and ratified the convention, this is binding law on them. And the California Consumer Privacy Act is one of the most progressive subnational privacy laws in the world. And so it's really kind of seen as the gold standard for protection, which is why you've used that. In other parts of the world, they're not binding laws yet, and so there are a lot of non-binding soft law frameworks, which are, in essence, advisory. And so we also compared what we found with these companies across those 3 sets of guidelines in the different parts of the world. So here's what we found, and I'm going to kind of go through this pretty quickly and then talk a little bit about the legal and regulatory framework and then conclude and open it up for questions. one of the, when you talk about access to information, there are three things that we're looking at. One is, can you find a privacy policy on the website? The second is, do the companies respond to outreach? And the third is, are consumers told if these agreements change? And what you can see here is that most of the companies had privacy policies, but much to our regret, and when you look at our outreach to the companies, 20 out of the 30 companies didn't respond to 3 requests that we contact them to say we have questions, we want further information, and so forth. So it begs the question, how can you provide informed consent to a user agreement when you can't even contact the company to understand what the agreement is or to ask any questions about it? And what you can see here is that only a third of the companies say that they'll tell you if there's an update to the relevant policy to the policy documents. In the case of unclear, you assume that they don't have any obligation to do it, because if they were going to do it, they would have told you. So really, about 2/3 of them either have said they're not going to do it, or in practical terms are not going to do it. Then we look at data collection and storage. One of the biggest questions for us, of course, in researching this is, okay, you have privacy agreements, but do you explain to users what neural data is and that you're collecting neural data? And it turns out that in more than half of the companies, the word neural data never appears anywhere in any of their policy documents, which means you can't obviously be giving informed consent to hand over your neural data when you're not even aware that there is neural data as a general concept, or that this device is going to collect it and process it. In addition, one of the major issues of concern in global privacy standards relates to data minimization. It turns out if you're using one of these devices, for example, there's a device that helps with overnight, sleep and analyzing what sleep level you're in, like an in-lab sleep study, but in a wearable device. And when you put that on overnight sleeping, it gathers terabytes of your brain data, right? Not just gigabytes, but terabytes of your brain data. And even a single snapshot can be gigabytes of data. So this is an enormous amount of data. And for any of these devices that are more rudimentary in the early days of consumer neurotech, really no more than 1% of the data collected is actually being processed. You can't selectively process currently today based on existing devices. You can't, for example, tell a brain scanning device to just scan this one part of the brain. You have to capture the full scan of the brain, and then you need to find the stuff you're looking for within it and process it. But the reality is that it's never more than about 1% of the data that's been collected, which means these companies have 99% of extra data, which could be used for any reason that they would want, and they don't need it actually to undertake the application that they say that they're going to do for you when you buy the product itself. And then there's also the question about how long is the data retained. At first blush, this looks like a pretty good number. Okay, 2/3 say that they have a data retention period, but when you look at actually what those periods are, they're like 10 years, or as long as we think it will be useful for us to keep your data, et cetera. So actually, really none of the companies have an especially good policy that limits the amount of time that they hold on to data. That matters a lot with neural data because, in 5 years, it should be very possible with generative AI, as well as the fact that these are MRI scans already. These are MRI scans. Once that product will go to market, that today with generative AI and EEG, you can decode 40 to 60% accuracy of a person's thoughts. In, let's say, 5 years or even less, you're going to be able to run that kind of software against the EEG scans that the companies are holding, and you'll be able to know everything the person was thinking in words, in thoughts, in their mind over the time that they were wearing that device. Who knows what you were thinking about when you were using the meditation device, and so forth. So data minimization is a serious problem, as well as the length of the retention period is a serious problem, because the longer they have it, the more likely they're going to be able to decode a lot more from it. Then you look at data sharing. Can the company share data with third parties? And can they sell it to third parties? So 2/3 of them say that they can share it with third parties, but the other 30% aren't clear, and not clear has to be presumed that they can, or otherwise they would say they don't, right? So what it means is that literally there's only one of the 30 products today that say that they will not share data with third parties. It's a device by a company called Unicorn, and in fact, the neural data that is gathered on the EEG scanner that they have is actually kept only locally on the device, is never sent to the company or into the cloud, and it self-deletes after each use. So I'm not suggesting that it has to be the practice of every company, because again, people should be allowed to hand over their neural data as long as they're well informed about what that means, and people have a right to informed consent. So I'm not saying that every company should follow the Unicorn model, but the Unicorn model is very safe and secure, and using that device, you can be quite sure that your data is highly unlikely to end up in anyone else's hands. So, and then in terms of selling the data, 2 companies say they actually do, 13% say they don't, so that's like 3 or 4 companies. The rest are unclear. Again, if they don't say that they won't do it, then in essence, they can. So now we get to what are the major user rights of companies, and the 2 most important user rights in the field of global privacy standards are, can you withdraw your consent to have the data processed? Tell them, I no longer want you to analyze, in this case, my neural data. And can you tell the company, I want you to delete the data? And the company will say, yes, we will respond, and we will delete the data. So what you see here is that half the companies allow withdrawal of consent, and a little less than half allow the deletion of the data at the consumer's request. Only 12 of the companies, 40%, actually provide for both. But the problem is you have to read these 2 slides and these results with the prior slide, which is about data sharing. Now, the problem is that it's not of much use to have a right to delete the data if the company had already shared your data with a third party. And the reality is that any of these companies, if they wanted to avoid the problem of ever having to delete their users' data, could even have a private standard operating practice that every time it gets uploaded to the cloud, they've created an independent company to receive brain data, and it's long since left their server and is no longer with them to be deleted, or they'll keep a copy on their server, but the copy is gone, and you can't claw it back. So on the one hand, you would say, okay, a lot of these companies allow withdrawal of consent and deletion of data, but because of the prior information that I've just presented on data sharing and data sale, this is a meaningless offer in really all but one of these cases, that one company that doesn't actually send their data to the cloud. Finally, let's talk about data safety and security. One of the big questions about data in general in these global privacy standards is about de-identification of data. And in a lot of contexts, you can de-identify data from a person. But the problem is with neural data, because neural data can be decoded to understand a certain narrow set of things today, but in the future, it will very likely, and it will, be able to be decoded to reveal a whole lot more information, right? So any company that says that they de-identify neural data, for example, the big question that a neuroscientist would ask, my colleague Rafael Yuste, is how do you do that? I mean, if you're keeping all this data, you can't say that this is de-identified. I mean, you can separate out the person's IP address from where they uploaded it to the cloud and separate it out from the brain scan, but you actually only know about 1% of what can be decoded from a brain scan today. And in 2 years, 3 years, 5 years, if you can decode a person's thoughts and the person is thinking about, doing certain things, or they're thinking about, very private things like I'm worried about my next cancer treatment, or you name it, right? How do you didn't de-identify the data just simply saying you did. It's all in there. It's just right now you can't decode it. So in addition, when you look at encryption, you would think that companies would understand the sensitivity of neural data, but only 20% of the companies, 6 companies actually say that they encrypt it. The rest are unclear. Again, if they don't say that they're encrypting it, the assumption is that they likely are not. Right, and then lastly, if there's a security breach, do you get told that your brain data may have been let out into the world? And the reality is almost none of them actually say yes. Only a handful of them say yes, that they'll tell you. The rest are unclear, but again, that means they don't have any obligation to do so. So our ultimate conclusion here, having looked at all of this, is that today, with the 30 products that you can buy online right now, consumers overwhelmingly lack access to information, which is very inconsistent with global privacy standards that require transparency and informed consent. You can't consent to having your neural data, captured and then used for various purposes if you don't even know that neural data is one of the things that the device captures, right? Further, the lack of information undermines, as I said, notice and consent, which is the model on which privacy documents are premised, because there's lots of information that's omitted. For example, that neural data cannot be easily de-identified, even though a number of companies claim to de-identify, right? So if you don't understand these things, you might think, oh, well, that's a relief, it's de-identified. Well, but how do these companies explain how that's actually going to work in practice? Because medically, that's not something that can easily be done. The other thing is that all but one of the companies really exercise significant control over the collection, storage, retention, or repurposing of the neural data. That is, in 29 cases, totally out of the hands of the consumer for the most part. Again, some agreements are better or worse, but at the end of the day, there are huge gaps here. And of course, the concerns are only going to become much more serious given the extreme sensitivity of neural data and the decoding as the decoding technology improves. So let me just I promise you I'm almost at the end here. I want to just kind of talk a little bit about the global legal and regulatory landscape and what we can do about all of this. So there have already been lots of actions undertaken by multilateral organizations and national and local governments, in terms of nascent first steps forward to come to understand and think about the problem. And so here, these are multilateral organizations and national and local governments that are either reporting on neurotech and human rights issues and starting to talk about it, adopting laws, that's actually only a handful of these, or issuing declarations, which are kind of non-binding statements of generalized principles that people should follow. For example, we worked with the UN Human Rights Council, which adopted a resolution asking its advisory committee to conduct a study into the human rights implications of neurotechnologies. And that's being presented to this upcoming session of the UN Human Rights Council. It's about a 50-page report. It's actually done a very, very good job looking at all the different issues and highlighting them and talking about the various ways in which these kinds of concerns can begin to be addressed. We're also talking at the UN to different UN treaty bodies that interpret international treaties, because as I was saying earlier, we believe that a lot of the potential misuse and abuse can be at least protected under international human rights law by further interpreting existing treaty provisions that are out there. And so one example is the International Covenant on Civil and Political Rights. About 180 countries in the world have signed and ratified it, covering 92% of the world's population, and there's a right to privacy in that treaty. Under Article 17. The problem is the treaty was written in the 60s, it came into force in the 70s, and that provision of the treaty was interpreted in what's called a general comment by the elected treaty body that under the treaty has the definitive right to interpret the treaty. That was adopted in 1988. And the current definition of international law of a right to privacy is you have a right to be free from, in essence, arbitrary interference with your privacy. But one question that raises is if a person was passively able to gather your brain data, but wasn't actually interfering with it, would it be an arbitrary interference to monitor and gather? And the answer is maybe not, right? Now you would think that mental privacy should fall within the rubric of privacy, but of course, when the treaty was drafted, nobody had any thoughts about where neurotech was or where it would go. But this can be rectified by this treaty body, which is called the Human Rights Committee, that has the job of interpreting the treaty for all of the members of the treaty, by amending that general comment to talk about how now that embedded within the right to privacy, there was always, and needs to be going forward, a right of mental privacy. And the exciting part about that way forward is that can be a 2 or 3 year process to reinterpret a provision of the treaty. And once that were to happen, all of the states parties to the treaty, the 180 countries in the world, they have an obligation under a different provision of the treaty to bring their domestic law into compliance with the requirements of the treaty. So if there's a new right of mental privacy embedded within the right of privacy, then those 180 countries are supposed to now provide a right of mental privacy for people around the world. Now that doesn't happen on its own, and it will be a long process to go to every country in the world and say, hey, you have this new requirement to protect mental privacy in your country and so forth. But this is a shorter pathway, for example, than developing a new treaty, which I don't think there'll be an appetite for because there are already 10 international human rights treaties. And a lot of potential misuse and abuse of neurotech is already prohibited under international law. So I talked about torture, right? There's a convention against torture, right? And inflicting severe physical or psychological pain on a person, is already defined as torture under international law when done in particular contexts by government and for particular purposes. Those provisions are method neutral. So it doesn't say it can only be this kind of torture or that kind of torture. It's just if it creates severe physical or psychological pain, it will constitute torture. And so what I described with this neurotech device would already be prohibited as torture under international law. You don't need a new treaty to protect a person from being tortured by a neurotech device. It still may happen, but it wouldn't be legal. It would already be illegal under international law. We've also seen that a number of one country in the world has actually taken a major action forward to specifically protect mental privacy, and that's the government of Chile, which became the first country in the world to adopt a constitutional amendment to protect mental privacy. And in fact, they've had a first case go all the way to the Supreme Court of Chile, where one of the 30 companies in our study had sold a product into Chile, in fact, by the guy who authored the bill, who then initiated the lawsuit. And the Supreme Court of Chile found that the product's sale in Chile violated the constitutional right to mental privacy because the user agreement kept the data with, with the company, and there were limited rights of, of deletion and of data minimization and all these other things that are expected to be there. We have 3 states in the United States right now, including Colorado, which is furthest out front, which has already passed an amendment to their state privacy law in the House, in the state legislature. It has to go to the Senate in Colorado. And this is a provision to amend the state privacy law to incorporate protections for neural data, which is being added to the definition of biological data underneath the Colorado Privacy Act. It turns out that if you look at state privacy laws, there's about 13 of them, that there are 2 sets of data that are generally protected if they can be connected to identifying a person individually, and that includes biological data, which has a broader definition, and biometric data. But actually, neural data doesn't fall as a medical question within the definition of either of those terms, because neural data is electrical and not biological as a technical point. And when you look at the definition of biometric data, biometric data are things like eye scans, DNA, fingerprints, et cetera. And it is all about capturing external representations of a person that are captured from outside of their body and then can be used to connect back to them to identify them, right? But biometric data does not include data that is within the person's body, right? So neural data is in a person's brain, right? And wouldn't be considered biometric because it's not an external representation of data that can connect back. And so in Colorado and California and actually Minnesota, there are actions underway to incorporate neural data, protection for neural data into the state privacy laws. That, of course, begs the question, though, of what's going to happen in the United States at a federal level. And our hope is that this report that we are publishing shortly will create a cry for some action there. We, a number of years, 2 years ago, met with the White House, the State Department, and key people there. And, the lights are on and nobody is home when it comes to Neurotechnologies. In fact, the Deputy National Security Advisor for Cyber and Emerging Tech, her role only covers 3 areas of emerging tech, which is supercomputing, AI, and biotech like CRISPR and so forth. And Neurotechnologies isn't even in her job responsibility, even though China is spending $1 billion a year through its military on neurotechnologies. And it was only more recently that the Office of Science and Technology Policy at the White House even hired a first person to start talking about neurotech. So we're going to obviously take our report to Washington as well and seek to meet people at the White House, the State Department, members of Congress. And at a minimum, people in the U.S. need to start to wake up and see what's happening and where things are right now. And hopefully, as I said, this will create some impetus for action. So we've written a whole lot about this. I'm not going to go through any of this, but I'll just throw this on the screen so you can see. Me and my colleagues published a journal article about how can the UN most effectively advance protections for neurotech through the various mechanisms that are available within the UN system. And you can see here lots of different things. Some of them have actually already happened. The UN Human Rights Council actually has already done a resolution and a report. And so there are different roles for different people to play within the UN system. At the end of the day, the most compelling one relates to, as I said, the treaty bodies further interpreting these provisions to address gaps that exist. But there's lots of other things that need to be done as well at the international level. We're not sitting around waiting for the UN to act, just to be clear. This is why we're already working at a national level in many different countries around the world already. And, well, obviously there'll be a lot more of that to come. We're also seeing other progress coming as well through lots of the different conversations we're having. So, for example, one of the most forward-leaning global privacy laws is the General Data Protection law in Europe, regulation, GDPR, which covers all 27 EU states, is binding law on all EU member states. And that is not a bill that will ever, that's not a law that will ever get amended because it took 27 countries to ratify it to even create it. But we heard from the government of Spain and from the Spanish Data Protection Agency that was created to implement GDPR in Spain, and they are very concerned about emerging neurotech, and they asked for our help in looking at GDPR and how GDPR would apply to emerging tech. And they're in the process of finishing a circular, which is a publication that they've done in different industry contexts that talks about how do these laws apply to a new sector or area of business or endeavor. And so, we've been helping them with that. They'll be putting that out shortly. And they intend to take that circular, which is about 15 pages long, explaining how one should think about applying GDPR to neurotech. And they're going to go to Brussels and meet with the European Central GDPR Authority and ultimately seek to get the support from other EU members that would adopt this circular as the definitive interpretation of GDPR. That would make a big difference because if you're any of these major tech companies, let's say like Apple, Apple just had to change, as many of you know, the plug that connects into your iPhone. Because they want to sell within the EU, and the EU decided that it was anti-competitive for them to have their proprietary plug. And they have the ability with the European zone and its size and scale, they have, even with Apple, some monopsony power, some buying power, right? And they compelled Apple to change its plug if it wanted to continue to sell iPhones into the EU. So I would imagine that if you can get a circular adopted by the central GDPR authority about how GDPR applies, which would include requirements for data minimization and obviously transparency and accountability and disclosure and the right to be forgotten, the right to have your data deleted, clearly informed consent when it relates to the transfer, sale of data, and all these kinds of things, then any major company like an Apple that's themselves right now developing a neurotech device for this very same reasons is going to have to do a better job than these 30 companies are so far at ensuring that global best practices for data protection are actually applied in this context. So the very last slide here, which is there is a role for company and their investors to play an important role actually. Obviously, we are not, the first part of our mission is to promote innovation in the field of neurotechnologies. And our job is not to stop, people from being able to voluntarily give up their brain data. Our view is simply that they need to be properly informed and have all these other rights that are found in global privacy practices in order to ensure that they have all the appropriate protections and that they're making these decisions consciously and clearly. And one thing that could go a long way in light of the enormous gaps that we found between the way these 30 consumer neurotech companies are currently set up in terms of their, policy documents, is to create a set of standards working with industry, and investors about how the industry will want to police itself. And if you subscribe to this set of principles and standards that are consistent with global data privacy laws, then you could say, I'm following the 10 guidelines from this coalition of neurotech companies and tech companies and so forth. And I think that could go a long way to raising the bar on the expectations and how these companies should operate and function. We've also talked as well with a number of other experts about the idea of a technocratic oath, and that anyone who's actually developing the technology and involved in then deploying it should subscribe, much like a Hippocratic oath for doctors, commit to a set of ethical core principles that they would follow in how they develop and deploy these kinds of neurotechnologies. So anyway, I've at long last come to the end of my remarks, but of course I'm more than happy to answer any questions that you might have, and I hope I've blown your brain today. I've covered a lot of ground. And please also say who you are and where you're from.
Neurotechnologies and their what you was already talking about, the fingerprinting and the there potential for misuse, and what are the privacy regulations that you might talk about?
Yeah. Thanks for the question. So I think there are differing views within the field of people that are talking about these issues, which I'm more than happy to mention other people's views that may not be consistent with my own. There is a debate underway about when you're talking about addressing the risks of misuse and abuse of neurotechnologies, how are you defining what neurotechnologies are and how far do you want to go? For our purposes, for example, we don't want to try to include neural data within an expanded definition of biometric data because we don't think it fits, and also because of the implications that might have. The reality is that biometric data has been around for decades, and there's a whole world of experts on biometrics in governments, in the private sector, and so forth. And the definition has been the same for a very, very long time. So we don't think it makes sense to try to change it. But there are also external signals from your body that can be decoded to interpret various things about you. So, for example, you can diagnose, in fact, from a person's eye scan and how their eyes move, a number of different brain diseases. And there are some people in the world that we're having these conversations who believe that should also be considered the equivalent of neural data, and that we should be protected against, for example, an involuntary scan of eye movements that could be used to decode, the fact that you have a brain disease. That's just one example. There are other movements of the body that can do that way. Our view is that is a slippery slope that for ourselves we don't want to get on, because if it's eye movements, then lots of different things from body movements could be decoded because we are habitual creatures and we do things repeatedly, right? And so what we don't want to do is to say anything the body does is now going to be considered to have come from the brain, which, while technically is the case, right, is a very expansive argument where you can imagine, for example, one person who's taken this position is talking about how they believe that those kinds of other external things should be monitored, and in essence, anything that is a biosensing device and that can decode anything about your thought or behavior should, in essence, be considered neural data because it's at least indirectly connected to it. But that would mean literally your television could be considered a biosensor, because, for example, if you watch Netflix every night from 12 a.m. to 6 a.m. local time, the company can decode that you're likely, you have sleep troubles, right, or you're an insomniac, right? So, to me, I don't see how we're going to effectively regulate this space if we just expand it out to cover everything that you can imagine, right? And I think that what I'm most worried about is neural data. It's not to say that I don't think, for example, how an eye scan could be decoded to identify a disease isn't something that should be protected. I think it should be, but it should be protected in a different way than neural data, which to me is especially sensitive in light of all the things we've been discussing today. So when it comes to other, the decoding of other things like intentions, and for me, if it's going to be decoded from neural data, then it should be protected in that special category of especially sensitive data that is neural data. If it can be decoded from other things, then again, I think you just have to look case by case and see where it might fit in. Could it be under biological or some other definition? But our view is that neural data is especially sensitive and especially important in light of our entire existence is being created by our own minds and what will ultimately be able to be decoded. There's every reason to believe that it's already the case, for example, and this has been done with a person who already had a BCI in their mind. You can connect a BCI to a person's visual cortex, and you can actually decode the signals that are coming from a person's eyes into the visual cortex and put it on a TV screen. Now, it's very rudimentary. It's not like watching television, but you could see images and shapes fade in and out and so forth. Eventually, you're going to be able to decode that and actually have probably a very high quality version of what a person sees. This is going to help cure blindness for people, and there are already people who are working intensely on that, where a person will wear a cap or a hat, a person whose eyes are not functioning, right? In essence, that image would be translated into the signal that your brain needs to receive it in the visual cortex and then pumped right in there. And it turns out that the brain is very flexible, and in a lot of different contexts, the brain, even if it's never been used before for a particular purpose, will immediately be able to adapt, receive that data, present it in the proper way, and actually decode it. Again, all very exciting things. But I think we're trying, in order to be as effective as possible to really stick narrowly to neural data, which we believe is the most sensitive data out there, and for the most part falls outside of existing current frameworks in the context of consumer products where there is really no regulation of any kind.
Hi, I'm Sue Ann Caulfield, and I'm a Latin American historian, and I was really fascinated. This is all incredibly fascinating, but in particular, it seems like the regulation is polarized. All of the countries that you mentioned, you didn't mention when these laws were passed or when the Supreme Court made the decision in Chile, but I'm assuming recently. So they're all progressive governments, and as are the 3 state governments, right? I mean, comparatively speaking. Yes. And so I'm wondering about this, the idea, like who's against regulation and why is this such a polarized issue? Yeah. And the other thing is, it seems clear that you didn't, I'm sorry that I had to come late, I had another event, but I don't know if you talked about policing and the police uses and the ways that in all of the countries you mentioned, there's a big concern with the ways that people's data is being stolen, and especially Israeli technology is used to get people's communications data. And so I'm wondering also about that relationship between, on the one hand, it seems to be more progressive governments that want to establish regulation, as opposed to other governments that don't, and the use of this kind of technology, potential use of it for policing and for controlling. Yeah. And then the last thing is that was that all of the countries in the world that have established regulation, or were those just an example?
Nope, those are all the countries in the world.
All in the world.
We were right
and
at the
they're all
beginning.
in the Americas, and so many of them
I'll explain why.
Are in Latin America and Spain. So anyway, I'm just curious about that as well.
So what you're seeing is actually a big result of my colleague Rafael Yuste, who's Spanish-American, and obviously bilingual, and he has relationships, especially in Latin America, Spain, et cetera. He is really kind of one of the world's leading experts on this topic. This is my colleague who I co-founded the Neurotechnologies Foundation with. He has an MD, PhD in all these areas as a professor of biological science and runs the Neurotech lab at Columbia University. He was one of the people that initiated the Obama Brain Initiative, and everybody around the world, if you talk to anyone in the field, knows exactly who he is. He's probably one of the 5 most published authors on neurotech in the world, right? So everybody is coming to him, but he has very strong relationships in Latin America. And so it's not that other countries are not interested in already moving. It's just he had easy relationships over a long period of time with people in the Americas. And so that's coincidence, not, I wouldn't read too much into it. For example, the Australian Human Rights Commission reached out to us. They were going to do a big report on neurotech, and we provided them a lot of advice and thoughts. And they've just published a big report in Australia about that. I mean, again, it's just a report from their National Human Rights Commission about concerns. But I think that the bottom line is that when it comes to who's opposed to this, there are different kinds of opposition that I would describe. There are philosophical differences between different people in the field. There's, for example, a whole field of neuroethics, which looks at all these issues through the lens of ethical development, right? And although many neuroethicists believe that we also have to change the law, many of them believe that these are not issues that should be solved by law, but should be solved by promoting ethical frameworks and guidelines and working collaboratively with industry and working these kinds of issues in a ethical context and not in a legal context. I suppose, if you're a hammer, everything you see is a nail, and I'm a human rights lawyer, so what a surprise. I think international human rights law is a good way forward. Although that's not, to me, human rights law is the only way forward, and while I am always happy to see more ethical frameworks and declarations that are not legally binding, at the end of the day, if you want to change behavior, you need, binding law, both at the international level and at the national level. And if you don't have it, then it's optional. And do we think, given the risks of misuse and abuse, that it should be optional, what is being done with respect to these technologies? So that's one kind of opposition, could be philosophical opposition. There's some in industry are strongly supportive of these kinds of things. For example, IBM is generally supportive of regulating neurotechnologies that are non-medical, so non-invasive devices. And there are other companies that are worried about constraints being placed upon them by users, I think, being very well informed, and a lot of users saying, this isn't really data I want to share, right? And The reality is that I don't see any scenario where ultimately these companies are going to not have to come on board, because we're already heavily regulating through global privacy frameworks in tried and true ways, going back decades of development of law, lots of other things that are much less intrusive, right, than neural data. And so I just don't see a scenario where we're not going to get to the point of making sure that neural data falls within these kinds of global privacy frameworks. So I do think it's very early days in terms of what is happening at a national level. I think the report that we'll be putting out soon, I hope will be a wake-up call for Washington that they need to engage and get involved. There is, for example, the Office of Science and Technology Policy, because AI, of course, is a massive issue in Washington and being dealt with by dozens of government departments and on the Congress and everything else. There is a national framework that came out of the Office of Science and Technology Policy for, the ethical development of AI. And, we should see a similar kind of process be initiated for the ethical use of neurotechnologies. And that's more, again, non-legally binding guidance, but creating expectations for industry. And then we'll need, different kinds of regulation. But at the end of the day, whether people will resist it or not, I just don't see, when people start to see, for example, which we'll see in the next probably 2 or 3 years, a wearable device that can decode your thoughts. I don't think there's very many average people who are going to read that news story and say, oh, I'm more than happy to let someone scan my thoughts and keep it for themselves. Maybe, but I really don't think so. And I think what we really need is a breakthrough moment like ChatGPT was for AI in the field of neurotech, and I believe it will be that device, which can already be done with a wearable device with 40 to 60% accuracy, decoding human thoughts. But when that gets above 90%, that will be the front page story from around the world. And all the people are going to say, well, great, we can do word processing with it and no longer type. But gosh, I'm really worried about, I'm sleeping and my spouse puts that thing on my head and is like tapping into my thoughts as I'm dreaming, for example. Again, I'm just sort of making all that stuff up. But I think that when it can be translated to the public at large, you're going to see a groundswell of support for proper regulation. Again, the goal is not to prevent legitimate research, not to prevent innovation. We want, my colleague, Dr. Yuste, is an MD, PhD and researcher at Columbia, at a major university, and he wants to cure brain diseases. For him, and understand the brain. This is what it's all about. And so he doesn't want to stand in the way or get in the way of that. But I think we're, again, still very, very early days, and people are kind of shaking out, for themselves, like what their positions are on all this. But I think ultimately, if this isn't a human rights issue, the content of our brains, then I don't know what a human rights issue would be. Because, as I was saying earlier, the mind generates everything about our entire existence and who we are as humans and our relationships and our emotions and our thoughts and our memories, how we interact with the world. Everything comes from our mind, which generates it for us. And surely, if there's any right to privacy, surely the content of your brain and all of the neural data that one day will be able to be decoded with much, much higher levels of accuracy than is possible today, or clarity, should be as protected as health data or financial data. And the idea that it might not be, to me, is a strange way of looking at it. Would be a strange way of looking at it. Not that we're arguing that, I'm just saying, for those that are sort of, for companies that are pushing back and saying, we don't really want extra regulation, we think that, this is all covered already, et cetera.
My name is Yara. I'm Lebanese from Michigan, and I'm a student in international studies and Middle Eastern and North African studies. My question is that there's a long legacy between neuroscience and racism. In this technology, do we see that also? Is this neurotechnology take into consideration diversity, race, gender, and we all know that always minorities, immigrants are more vulnerable to be victims and This was my question.
So, one of the 5 neuro rights that we've identified of core concern to us is a right to be free from discrimination in the development and application of neurotechnologies fully and completely. And that is of enormous concern. Most of the major developments in neurotechnology are coming from the United States, 85% really. And there's, in terms of at the highest level of developing neurotechnologies, the rest of the world has much more limited experience or experts and so forth. Undoubtedly, as one develops neurotechnologies, the only way to do that effectively and successfully is you need to be developing these technologies against every kind of diversity you can imagine, right? If you only do brain scans of a certain people of a certain nationality or religion or whatever, it's going to skew your results. To give you an example of what I mean, if you and I both look at the same picture of a black cat, our neurons in our visual cortex don't fire the exact same way, right? They're differences. Generative AI is now powering the ability, for example, to have, and by the way, a single brain scan that might do that could be a gigabyte of data, right? But generative AI is now powering the ability, for example, if researchers were doing 10,000 brain scans and it was a diverse group of people from around the world, then you would actually be able to know for an image of a black cat when a person sees it, here's the range of what the neurons in the visual cortex look like around the world, and you'd be able to use that generative AI to, in essence, decode any person in the world seeing an image of a black cat. That will only work if you're doing the research in a way that is incredibly sensitive to and understanding of the diversity of the human experience and all the ways in which people's brains work, all around the world from every context that you can imagine. So anyone who wants to do a good job developing neurotechnologies, in my view, would be foolish not to consider these ideas. But we are making zero assumptions that will happen, right? Which is why, as I said, protecting from algorithmic bias and ensuring the ethical development and application of neurotechnology on non-discrimination principles is, incredibly important. That is one area of concern that I think is enormous. Another area of concern that I'm more worried about is we've started to see some developments in nascent laws, for example, in Latin America. But what I'm really worried about is that for most countries in the world, this is not going to be a pressing issue because they don't really have a neurotech industry. They don't have scientists and researchers that are doing research into neurotech. And the number of devices that might be sold into their country is not all that high. Maybe over time they could be more if they, these devices from Apple or Meta, et cetera, they'll be much more widespread around the world. But what I'm worried about is a legal and regulatory framework globally, which is why we're working things at the UN and also nationally, that would in essence, have countries that were more aware of and sensitive to these concerns, adopting laws, rules, and regulations that would require companies to provide these kinds of protections. But you could easily see a scenario where these companies have two agreements, and one is for the list of countries that have actually regulated this, and then you have the rest of the world, and the rest of the world agreement could be an agreement that in essence enables companies to suck out your brain data and do whatever they want with it under any circumstance, and you don't know any different because you're from some country that hasn't thought about even regulating these issues. So I think it is important to bring the world collectively around all of this. My own view from all that I've learned in the last 4 years working on these issues, and again, I'm not a medical doctor or scientist, I leave that to my colleague, Dr. Yuste, but have learned a lot from him, is that there's a great urgency to advance these efforts, not just in places where it's rich in, investment or research into neurotech, but we need to raise global awareness about what is coming. And I think that, as I said, having a wearable device that can decode a person's thoughts is something everybody in the world will understand the moment that happens all around the world. And all of a sudden, we will go from a world in which most people have no idea what neurotech even is, or that it exists, or what it can already do and what it might be able to do, into a world where now everybody's going to start to ask questions like people asked about ChatGPT. Of course, there are large swaths of the world that people have no idea what ChatGPT is or even AI. So I'm under no illusion that the breakthrough in focus, public focus on AI, is a global phenomena. It's pockets of the world, where these kinds of issues matter. But I do think that part of this is why we're kind of working this also at the UN and trying to further interpret international treaties to provide a right of mental privacy, because there are 180 countries in the world that have signed on to this International Covenant on Civil and Political Rights. And that would then give us a good reason to go talk to all these governments, the 180 governments, and say, well, now there's a new right of mental privacy embedded in the right to privacy. We want, and an NGO like ours and lots of others around the world will be able to then, work with, governments that are like-minded to, for example, set up training and technical assistance programs for countries to look at these issues, et cetera. And if there's a new legal obligation to do it, even though, again, lots of countries ignore their legal obligations, at least that provides like a way forward where we can mobilize people to not only provide protections uniformly around the world, but also with the kind of principles that I've been describing, including, and the most important one of all, I mean, just as important as non-discrimination to me. I'm not going to say anyone's more important than the other. They're all five are important. But fair access to mental augmentation is going to be a gigantic issue, not in the next 2, 3, or 5 years, but definitely in the 5, 7, 10-year range in terms of what will be able to be done in enhancing memory and these kinds of things. And this will take the have and have-nots differences in the world, between countries and between peoples, right? And that inequality will grow exponentially rather than rapidly as it is now. I think we can't even begin to imagine the differences that are going to happen between humans, for example, that can enhance their short and long-term memory, and those who cannot. And what implications does that have for your entire life, for your work, for your productivity, for what you're able to achieve and get done? I mean, let alone like the personal life you have with your family and everything else. And so, this is not like an immediate term conversation, but this is not so far away that we shouldn't start to talk about these questions. We need to start talking about these questions now. I don't have any easy answers to these questions. And again, this isn't like a 1 or 2 or 3 year problem, but people need to start to understand what's coming, and it's inevitable. And there's no way the genie's going back in the bottle. We have to understand it's coming and prepare for it, and understand that our reaction as an international community is not going to be perfect and is going to have challenges and problems. And there are lots of ways in which this technology could be misused or abused. But what we're really, really trying to do is to raise global awareness and to move as rapidly as possible as we can to educating the wider public about this. Because at the end of the day, when people, as I said, see a breakthrough moment like people's thoughts being decoded with a wearable hat, I think that will capture the public imagination globally, and people will be both excited about it and scared, right? The reality is that there are lots of people who have been diagnosed as paranoid schizophrenics who believe that the government has implanted chips in them. It's a very common delusion among people who are paranoid schizophrenics. I hear from a parade of people who are paranoid schizophrenics and who I believe to be paranoid schizophrenics. I generally can't engage with people like that because the advice I got from a psychiatrist was that if you engage and try to help them and they don't know you, then they're going to immediately think you're part of their delusion, like part of the delusion of a government conspiracy to shut them down. They're going to think you're their enemy. And people like this, in certain cases, can be quite dangerous. But for all the people in the world that think that chips are being implanted in people, all different ways, it's also going to spin out globally in lots of ways that we can predict now and we should be thinking about.
So we have time for one more question. Then unfortunately we have to wrap it up. We're already.
Hi, I'm Chris Flautner from Computer Science and Engineering. So I don't have a very good perspective on the law part of this. I've been complying with those laws, but don't quite understand the logic behind them. And I guess that was actually my main question here. It seems like there's a big opportunity to actually rethink what privacy rights ought to be. And the trigger is neurotechnologies. But to me, it's not about neurotechnologies because a lot of what you're actually talking about exists today. I mean, the right to mental privacy is we haven't had for a long while since we've been using mobile phones and Instagram and all that stuff. So to me, all of this stuff looks like degrees as opposed to a brand new world. But perhaps from a lawyer's point of view, this looks like a very different part of the regulatory framework. But just as an example, from a camera, you can do these type of correlations that you talk about. You can do that today. You can, pick up on micro expressions, and people do that. You can use it for advertising. You can influence people's thoughts. And it is, by and large, well, it may be regulated, but it's certainly not complied with, as far as I can tell. Even, I think it was last week or this week, an article in New York Times on LexisNexis and how, unknowingly to people, data from cars about your mental behavior and how you accelerate and decelerate is being sold and used for insurance. So there's all this can of worms in the world today, and this might actually be a trigger to come up with a better framework and regulation around it so that it's actually transparent because, and I guess that's my question, is that how you actually intend to do that? And do you actually have a better framework for privacy in a more ideal world where actually we do solve these problems as opposed to just kind of deal with them in pockets?
It's a great question and a very challenging one, of course. A couple of people could write some dissertations on that topic, I would think. I think as an international human rights lawyer, I try to kind of deal with the world as it is and shape it to try to become a better one. But I try to be very grounded in the practical realities of the world that I'm living in. and by that, what I mean is that, I fully agree with you that lots of information coming from us, from our mobile phone use, from the way we interact with the internet, from, the way we interact with social media, all these kinds of things are, you see advertising or influence, all these things are, of course, influencing our thoughts, our beliefs, our ideas, and, who we are as people and all the rest of it. So that clearly is happening in a very widespread way. I think that the difference, and the reason why we see neural data as being different is because the kind of things that can be decoded from your neural data are things that most people can't even begin to imagine. And ultimately, we're going to be able to decode mostly everything about how our brain operates and functions, and all these things about ourselves that we may not even realize. And I think it's one thing to be influenced by advertising. When you see an advertisement on TV, they're trying to advertise you. Sometimes maybe it's more subtle, you wouldn't notice it. But the issue with neurotech is when you're talking about bi-directional communication between a BCI and the person's brain, and being able to decode a person's emotions, which, by the way, you can already do. There's a wearable device that can detect 20 different emotions that you are currently thinking, and it can tell you if you're angry or sad or lonely or these kinds of things, and that's already possible. But I think that we have to be very careful about getting to a point where, with wearable and implantable devices, that bi-directional signaling can actually where you won't even realize that the reason why you're doing something is because your neurons and your brain activity has been adjusted with a device so that you now believe you want something, but and you're not going to realize it's actually coming from the external stimulus of the BCI. With advertising, you see a poster driving down the highway, and you all of a sudden get hungry because you're hungry. You didn't realize you were hungry, but then you see something, you pull over and get some food. You know that that's coming from the outside in, but there's the danger as these technologies advance, in these kinds of influences coming from the inside out, right, and being programmed. And I think that, again, it's over the horizon. We're not there, but it's not so far over the horizon that this isn't going to be happening in most of our lifetimes. So I do agree with you that it would be useful to rethink conceptions of privacy, and how does decoding of the human brain impact all of those notions, because what is in our brain impacts so many different aspects of who we are as humans in ways that any other kind of technology can get a sliver of who we are and influence who we are, but only in a narrow way. But brain data and neural data is going to be able to blow that out in a really, really big way. At the same time, there have been decades of experience with global privacy frameworks. GDPR in the EU is one of the ones that are best known. And when I was talking about it kind of being grounded in what's possible and not possible, for example, right now it isn't entirely clear whether or not actually neural data, because of it being electrical and not biological, would fall within GDPR. Because one of the other requirements of GDPR in Europe is not only that it fall within one of the categories of data that they have identified, but that also it can be personally identifiable back to a person, right? And right now, today, if you were to take one of these consumer neurotech products and you had a person's IP address and their brain data, and you ran software against the EEG scan that exists today that could diagnose a number of different brain diseases, you could see how, in narrow ways, brain data today actually could be already personally identifiable. But as large tranches of brain data are being collected, and what we're going to see with brain data is going to be the same kind of process that we saw with genetic data with genetic testing companies. When they first started, there were no databases of genetic of people's DNA, and today there's like 50 million samples around the world that have been cataloged. A person's brain scan, by the way, is the equivalent of a fingerprint for a person, and they're going to be building databases of people's brain scans, right? And the problem with the protections of GDPR is that today we can only do a narrow amount that might be personally identifiable with brain data, but that very same data, if held onto by a company for 5 years, 7 years, you're going to get a massive amount of additional information out of there that may or may not be personally identifiable. It depends on what the person's thinking and at the time that the scan was taken. And so I think I don't see any scenario where we're going to be able, for example, to argue we should abolish the GDPR and start from scratch globally, because there are some basic principles that I think have been built into the privacy of personal data at the EU level and in global standards around the world, and at the national level as well in certain countries, and the state level in the United States, right? And those principles are pretty well defined in terms of, the 5 categories that I was talking about earlier that our study looks at, looking at the right to information, looking at how much data is being collected and the requirement of data minimization, looking at your ability to decline to have your data sold or shared with any third party, your ability to demand that your data be deleted, a right to be forgotten. Right? These are all generalized principles that kind of come out of the GDPR and other related instruments, and I think that they apply to neural data like they apply to all other kinds of data. And so, again, I don't think we're going to rethink all that. But I do think that as we start to understand the implications of where the decoding of neural data is going to go, there are enormous implications of all different kinds that none of us have even begun to think about. And, for example, my colleague Rafael Yuste said, probably 5 years, we're going to be able to decode our subconscious thoughts. Not just our actual conscious thoughts, but our subconscious thoughts. And what will that mean? That when we can understand what our subconscious is thinking, and how will then having knowledge of what our subconscious is thinking influence our thoughts about that topic, right? And so there are just so many different scenarios like that and that's just one very narrow scenario of one narrow piece of like neural data that will be decodable, right? And yet we haven't even begun to think about the implications of it. So on the one hand, we need to be forward thinking and try to get the world to focus on these issues and try to address these concerns. But we're only going to be able to see so far over the horizon because of how extraordinary these developments are going to be and our inability to really accurately predict which of these are going to have the biggest impact and why, and let alone how to protect against the misuse and abuse of this kind of data. So that's about the best I could do with a short dissertation on the topic.
Thank you so very much.
Thank you.